Hey everyone. Now that we're back from winter break, we're going to take a little bit of time here just to review optimization, get a little more practice with those types of problems before we quickly move in here to related rates. So for this video, we're just going to go through two problems. One is similar to ones you've seen before, and then the second one's kind of a novel type problem. But we'll go through just so we kind of warm up our brains on how these problems work. So our first one, these are AP type questions. So a rectangle is to be inscribed in a semicircle of radius 8 with one side lying on the diameter of the circle. So let's see what that looks like. So let's see. I have a semicircle of radius 8. So I'm just going to make this 8 here. And this will be 8, and I'm going to draw in my semicircle. Not great, but not too bad. Okay, so there we have our semicircle of radius 8, and what we want is a rectangle that's inscribed there. So that means the vertices are on the semicircle, and then again, that other side is on the diameter. And so we want to know what's the maximum possible area of the rectangle. So we need to come up with a formula for the area of this rectangle. So here's what I'm going to do. I'm going to call this x. And then I'm going to call the height of my rectangle y. So if I'm talking about the area of that rectangle, I know the area is actually going to be 2x. That's the area of the base, and then the height is y. Now, obviously, we need to get area just in terms of x. So I'm going to express y as a function of x. And here's what I know. If I have the function or the graph of this, the equation of this circle would be x squared plus y squared equals our radius squared, which is 64. So now I'm going to solve that for y. So if I do that, I would get y squared equals 64 minus x squared, and then y equals the square root of 64 minus x squared. And again, I'm only taking the positive square root because we just have a semicircle. So now I have something that I can substitute in for y, so I just have area in terms of x. So now I know my area is 2x times the square root of 64 minus x squared. So now I have my area in terms of x. I'm going to call that a of x. And so now all that's left to do is take the derivative, set it equal to 0, and then solve for that x value. Now, one thing we need to be careful of here, and something that gets missed a lot, is be careful to use product rule here. So my one function is 2x, and then I have times my square root of 64 minus x squared. So my derivative, I'm going to take 2x times the derivative of the square root of 64 minus x squared. So that's going to be times 1/2 times 64 minus x squared to the negative 1/2. And now I have chain rule, so I have to take the derivative of the inside. So I have a negative 2x. And now I'm going to do plus the square root of 64 minus x squared times the derivative of 2x, which is just 2. So let's clean this up a little bit. I can cancel these here. So I'm going to have a negative 2x squared over the square root of 64 minus x squared plus 2 times the square root of 64 minus x squared. And I want to find out where that's equal to 0. So I'm going to just move this over to the right-hand side. So I get 2 times the square root of 64 minus x squared is equal to 2x squared over the square root of 64 minus x squared. So now I'm going to go ahead and cross multiply here. So I'm going to multiply both sides by the square root of 64 minus x squared. So when I do that, the square root of 64 minus x squared times the square root of 64 minus x squared is just going to be 64 minus x squared. And that's equal to then 2x squared. So first thing I'm going to do just to simplify is divide by 2 on both sides. So I get 64 minus x squared is equal to x squared. And now it's pretty simple to solve. So 64 equals 2x squared, which means x squared is 32. And x is equal to the square root of 32. Obviously, we're not going to take the negative answer because we're talking about a length here. 32 is 16 times 2, so x is equal to 4 root 2. So now, let's go back to the question, see what's actually being asked of us here. The question was, what is the maximum possible area? So the question is asking us to find the area. So I'm going to go ahead back to my area formula and plug in my value that we found for x. So we said x was equal to, and I'm actually going to leave it as square root of 32 to make plugging it in a little bit easier. So now if I take the area of root 32 is 2 times the square root of 32 times 64 minus root 32 squared. My work's starting to run into things here. Sorry about that. So I get that's equal to 2 times the square root of 32. Square root of 32 squared is just 32. So if I take the square root of 64 minus 32, that just simplifies to the square root of 32. So now my area is just 2 times 32, or 64. And I don't have units for this problem, so that is our maximum area, which is choice E. Okay, so we've done problems similar to that before. Let's go ahead and look at the second one, which is a new problem we haven't really seen before. So in this case, here's what we're looking at. We have a type of fencing that comes in rigid 10-foot segments. So that's what's represented by these 4 sides here. So 4 uncut segments are used to fence in a garden on the side of a building as shown in the figure. What value of x will result in a garden with the largest possible area? So again, we're trying to maximize our area. So we're first going to find the value of x, and then we'll find out what that maximum area is. So let's think about area here. If I'm going to find the area of this garden, I have 2 things to consider. I have the area of the rectangle, and we know that's just the base, which is 10, times the height. Well, if this is x, I know this distance is also going to be x. So I have 10 times 2x, or 20x. And then I have the area of the triangle here, which we know is 1/2 times the base. Our base is 2x. And then times the height here. And so if I simplify, I have x times h. Now, here's where we have to be a little careful. We need to somehow find the value of h in terms of x, because if I differentiate this, I want to ultimately find my total area just in terms of x. Now, if I know this is a right triangle, I know that x squared plus h squared is 10 squared. So now if I rearrange this, h is the square root of 10 squared, or 100, minus x squared. So now I can plug that in here, and I have the area of the triangle is just x times the square root of 100 minus x squared. So now if we're trying to maximize the total area, I'm going to say area total is just equal to the area of our rectangle, which is 20x, plus the area of the triangle, which is x times the square root of 100 minus x squared. So now I have a function in terms of x that I can differentiate and set equal to 0. So a prime is equal to, the first term is easy to differentiate. That's just going to be 20. Now here again, we have to be careful. This is another product rule. My first function is x, and then I have times the square root of 100 minus x squared. So I have plus x. I'm going to differentiate my square root. So times 1/2 times 100 minus x squared to the negative 1/2 times negative 2x. Again, here's my chain rule piece. and then plus the square root of 100 minus x squared, and then the derivative of x is just 1. So I'm going to do a little bit of cleanup here. Let's see, my 1/2 and my 2 cancel out. So I'm going to get 20 plus negative x squared over the square root of 100 minus x squared. And then I have plus the square root of 100 minus x squared. And I want to know where that's equal to 0. So now I'm actually going to use my calculator to solve that one, just so we remember kind of how we can use that to help us out. And so what I'm going to do is I'm just going to put this derivative into my y equals. So I'm going to type it in exactly as I have it, being careful with my signs. Let's see. And hopefully if I type that in right, I'm going to graph it here. I'll have to change my window. Okay, so I can see in my graph here I have 2 zeros. Now, if we're talking about dimensions here, obviously we're not going to consider our negative x. So let's go ahead and use our calc function to find out where this 0 occurs. So I'm going to go calculate the 0, and I'm going to scroll over here until that kind of left bound comes into view. There we go. So I'm going to stay above the y-axis there. Then my right bound, I'll go below the y-axis. Hit enter for my guess. And to 3 places, we have x is approximately 9.306. So that tells me this value of x here is approximately 9.306 feet. So that's the first question. What value of x will result in a garden with the largest, whoops, I'm pointing the question up here. What value of x will result in a garden of the largest possible area? So here's the value of x. Now I want to find out that total area. So I'm going to go back to this equation here and then just plug in my x value. So I'm going to say a of 9.306. And we'll go ahead and plug that in. So being careful with my parentheses, 20 times 9.30, oops, 30. Goodness, it's the day before break, so that's why I'm a little rough here. Okay, 9.306 plus 9.306 times the square root of 100 minus 9.306 squared. And that gives us an area of 220.183, and this is area, so we know it's square feet. So again, this was just meant to be a refresher on how we work through these optimization problems. Tomorrow you'll have a day to just practice different types of problems, and then we'll be moving on to related rates.